Okay, so now let's look at multiplying a binomial with a binomial. For example, here x plus 2 times x plus 5. Now we're going to use a rectangle again to kind of demonstrate it. So this time our length is going to be made up of, so we'll stop it right here, like x plus 2, and our width might be represented by x plus 5. So we'll draw a rectangle made up of those pieces. So if we considered the large rectangle, we would say that it was represented by x plus 2 times x plus 5. So let's see what happens when we do it in separate rectangles. So this top left would be x times x. The area would be x to the second. Then this right top right rectangle would be a 5 and then represented by an x. So 5 times x is 5x. This rectangle would be 2 times x, which is 2x. And the bottom right would be 2. So 2 times 5, which is 10. So it's going to be made up of, I think I ran out of room over here, x squared. Then 5x and 2x is 7x. And then plus 10. You'll see that over there. I'll pull that over. So x squared plus 7x, and then that's a plus 10 right there. So that's how we could use it to do that. So if you notice, we're multiplying x times both the x and the 5, and the 2 times both the x and the 5. And that's what we're going to do as we work through these problems. We're going to use the distributive property twice, and we're going to take this first term, a to the second, and we're going to distribute it through a plus 2, so times a plus 2. And then we're going to take this plus 1 and distribute it through that second parentheses as well. So you can see that's what we did here, x times, oops, can't see that, can you? X times x plus 5, and then 2 times x plus 5 to get these numbers. So a squared times a is a to the third. A squared times 2, that's a positive 2, a to the second. Then a positive 1 times a, so a positive a. And then 1 times 2, that's a positive 2. We'll look to see if there's any like terms, and there are not. So that's going to be our final answer right here. I'm going to drop down and look at this one right below it, where I have n minus 3 to the second power. So remember that whenever we expand a power like this, we take that parentheses, n minus 3, and multiply it times itself. So this is the parentheses n minus 3 squared. So n minus 3 times n minus 3. So now this looks like a binomial times a binomial. So we're going to double distribute and do n times n minus 3, then a minus 3 times n minus 3. So that negative 3 is going to look like this. Then distribute and get n to the second minus 3n. Here I have a negative 3 times n is negative 3n, and a negative 3 times a negative 3 is going to be a positive 9. Then look for common like terms. So those are like terms. So I have n to the second minus, and I'm going to add negative 3 and negative 3, which is negative 6n. And remember, Powerman says that if you're doing addition, you do nothing with the exponents. So my 1s stay 1s, and then plus 9. And I'm going to, we'll come back and do B and D in class next time. So now just multiplying polynomials in general, let's take a look again with our area situation. So I have 3y minus 4, which is represented here. And when I have the minus 4, I'm going to put negative 4 right here. And then my y squared is going to go above the first column, and then a minus 5y in front of the second, and then plus a positive 7 right here. So when I do this, that's going to represent this. So this is then equal to 3y times y squared is 3y to the third. 3y times a negative 5 is negative 15y to the second. Add those exponents. And then 3y times 7 is 21y. Then negative 4 times y squared is negative 4y squared. Negative 4 times negative 5 is 20y. And then negative 4 times 7 is negative 28. So again, it's like a distributed twice on that. I'm going to look for common like terms. And let's see, the 3y cubed. So that's going to be 3y to the third. And then you can see in this little diagonal here, they're both y squareds. And they will combine. So it's a negative 15 and a negative 4. Gives me negative 19y to the second. Then in this diagonal, they're both y, so they're like terms. So 21 plus 20 is a positive 41y, and then minus 28. So we will double distribute down here. We'll take our 5m and multiply it times every one of these terms, and then we'll take our negative 1 and multiply it times every one of these terms. So I'll write this out that first time. So 5m times 2m squared plus 3m minus 7, and then a negative 1 times 2m squared plus 3m minus 7. So distributing, I'm going to get 10m to the third plus 15m to the second minus 35m. Then I have a negative 1 times 2 is a negative 2m to the second. The negative 1 times a positive 3 is negative 3m, and the negative 1 times the 7 is going to be positive 7. If it helps you to remember, the other thing you can do is make sure you remember that is you can call it plus a negative 1 so that you're sure that you're distributing a negative 1 through. We'll finish this next one in class next time, so I'm going to stop this video. Okay, again, just kidding, because I can't stop it yet because I need to combine like terms. So the 10m cubed, you see, has nothing to combine with, no like terms. So I'm going to do that. Then I have this 15m squared and a minus 2m squared. So plus 13m to the second. Then a negative 35m and a negative 3m is a negative 38m, and then plus 7. Now I'm finished.